Hello, in this video I will show you how to use Graphmatica, the calculator, and also some functions in the Word document by using vectors and the documentation, how we are making some calculations about vectors, and we also can show it in the sine curves in Graphmatica. We'll begin in Graphmatica, and if we're going to have shown a function, we have to spell y is equal to. And if we're going to have a sine function, we for example can have a sine function with a maximum of 45 volts. We have to key 40y multiplied by sine, and then we have to use brackets. And it should be sine for x, because our x-line, that will then be the degrees, that the angle of the sine curve, and then we can, at the y-axis, look at the value for the curve. Normally, Graphmatica, it counts in radians, so after the x, we have to key in d for degrees. We enter brackets and enter. So now we should have seen that it should have been a sine curve, and the reason why it looks different is that our y-axis only goes to 3.5, positive and negative, and the x-axis only goes from minus 7.5 to positive 7.5. So we have to adjust the axis so that we can see an angle for example, minus 400 degree to positive 400, and the y-axis for plus minus 50 volts. Here I have a Danish version, but you can see which column you are in, and in the English version you just can choose the third column, and then you can number 4 in the row. I think it's called graph area. In the Danish version you can also press Ctrl plus R. So then we can key in left side, that was minus 400, the right side positive 400, the bottom minus 50, and the top positive 50. And now we see we have a smooth sine curve, and it is going positive when the angle is 0, and we have one complete revolution, or one turn of a generator, for example, in 360 degree. We also can see on this side of 0, and we have negative numbers. Actually, when we are looking at sine curves, if we're going to make another curve that is 30 degree after this one, and if the sine curve is after, that means it has a negative angle, then it should be this way. And actually it was better if these numbers were negative and these numbers were positive. But in Graphmatica it is a coordinate system, and then normally we have positive values to the right. So maybe we could wish that these were negative and these were positive, but I think it's not a major problem. So The other voltage we want to key in can be, for example, 30 in amplitude, and then it should be twisted. It has this phase shift of negative 30 degree. We also have to remember to put in a lowercase letter d, because otherwise it will calculate in radians. Now we see that we got another function, sine curve. It has a phase shift, it is lagging 30 degree, and has an amplitude of maximum 30 volts. If we are working in effective values, we then should multiply by square root 2 to get the maximum value. So here we have, for example, the voltage curve of 45 volts in the angle of 50 degree. We have about nearly 35 volts at the instantaneous value right here. So, and then if we should add these two sine curves, we can take the instantaneous value for every time. For example, here in 20 degree, the 45 volts has an instantaneous value of 15 volts positive. The other curve has a value of negative 5 volts. So the sum of these two values should be about 10 volts. So if we add these two sine curves, we want to have an instantaneous value here at 20 degree of 10 volts. So let's see. We have selected the curve with 30 volts. Then we can mark the function, press Ctrl C for copy, select the other sine curve, make the cursor up here, press plus and Ctrl V to insert the other function and or to pass the one we have copied, and then when we press enter, we have the sum. Now we can see that it's about above the limit of 50 volts, so we have to key in again the area, and I think, for example, plus minus 70 volts. That will do. We can see that it's nearly enough. Another opportunity we have is to show that just below graph area we can find all graph. So if we press this key, it automatically zooms in and out, so it fits the screen. Now we can see the sum of the two vectors, two sine curves. It has a maximum when we put the cursor up here. Then we can see at the left bottom, down here, the value of the point of the cursor. I will show you by returning. So the value up here, we can see it has a phase shift about 101.9 degree, and have a maximum value of 72.5 volts. The phase shift from the reference at 0 degree, that must be when the sine curve going positive and crosses the x-axis. And we can see that is in an angle of 11.9 degree. Now we can try to check the result by using the calculator. The first value, that must be the 45 volts in second 0 degree. So we press 45, enter. Since it is in 0 degree, that's the reference, it is not necessary to put in the angle 0. It is just a real value. The next one, it should be 30 volts in a negative angle of minus 30 degree. So 30, enter, 30 plus minus, and when we have to switch to custom menu, and we are in R angle set, and we press arrow V2. Then we have the 45 volts and the 30 volts in the negative angle, and we take the sum by pressing plus. Now we can see it gives 72.5 volts. Yeah, that's correct, and the angle is negative 11.9. Exactly what we got in Graphmatica. Now we can try to make some vectors in Word. We have to insert, figure, and choose an arrow. Make a straight line arrow to the right, and then we just can make some adjustment. I think black is better, and I can make it a little bit wider. So now I can see, control, check the size of the vector. I can see that the height is nearby 0. We just have to adjust it a little bit, and the length or the width is 9.08. We have that the voltage should be 45 volts, so for example we could make the length 4.5 centimeter, or we just could set it could be 9 centimeter, the double. So it means that if we take the calculator, we have the 45 volts, and if we multiply by 0.2, it gives us 9 centimeter. The 30 volts, we have to multiply also by 0.2. Then the length should be 6 centimeter. So we'll do that. We can mark the vector or the arrow, press Ctrl C and Ctrl V to copy the vector. Right click the vector and make some adjustments. The size, now the length or the width should be 6 centimeters. And now we have to rotate, and it should be a negative 30 degree. But in Word, if we have a positive angle, it rotates clockwise, and that is also the direction that we want, because in vectors a clockwise rotation is a negative value. So press OK, and we can see that the vector is rotated negative. Then we can move the vector so they have the same point, beginning point. And we also can make a copy of this vector and place it at the end of the other vector, because we have to make the sum of the vectors. So the sum of the vectors is a vector that starts here and ends up here. We can also take this vector and copy that and place in the bottom. So we can ask the calculator the length and the angle of the sum of the two vectors. If we are going to have the length in centimeters, we have to multiply by 0.2, and then we can see that the length should be 14.5 and the angle negative 11.9. So make a copy of one of the vectors, make a right click and adjust the size to 14.5 and the angle to 11.9. And if we just rearrange it, we can see that it starts up here and ends down here, and it seems that it's okay. We can delete these two vectors if we don't want to have them. Then we can see by graphically, by using vectors, the sum of 45 plus 30 in an angle of negative 30 degrees is 75 in an angle of negative 11.9. We also can make a documentation of how we calculate it. Here I use, in objects, I use the Microsoft equation. Because in equation there is many symbols and so on, so that we can get a well documented calculation of vectors. In vectors we have to have a line above the vector, and we can have it right here. Then if we says this vector plus this vector is this vector, we call this vector for v1, this for v2, and the result for v3. So we have to key v, and then then we want to have the index for the v. We press Ctrl L to lower and 3. Then we press the right key, then we are back to the v, and the right key again, then we are out of the right line, which indicate that it is a vector. v3 is equal to line again to show it's a vector, v, Ctrl L for lowering, it's v1, 2 times arrow to the right, plus line above to show it's a vector, v, Ctrl L for lower, 2 times arrow to the right. That is equal to, and then we have to key in the numbers. It was 45 volts. Then we have to make an angle sign. We found it here. And that was an angle of 0 degree plus 30 volts, an angle of negative 30 degree. And that is equal to. It could be nice if equation could make this calculation automatically, but we just have to get the number from the calculator. Now we should remember that this was the length of the vector, so that we have to make a division of 0.2 to get the original value, and that was 72.5 in an angle of negative 11.9. So 72.5 in an angle of negative 11.9. That is volts. If we got to have a, we can press Control to get some space, and then V for volts. If that is a result, we can make a double line under right here, and now we got the documentation how we calculate the sum of these two vectors and get a result. So now, using vectors, calculations, documentation, how we use the calculator, and also how we use Graphmatica to make some sine curves. That's all.